Hi guys, so we're going to go through the practice sheet that we did in class on Friday that I told you guys to work on over the weekend. Okay, so number one, the degree here is 4. Leading coefficient is 3. We get that from this first equation up here. So based on that, if it's an even degree with a positive coefficient, leading coefficient, we know this graph's going to open up on both sides. So the left-hand behavior is as x goes to negative infinity, y goes to positive infinity, and same thing on the right. But this time x is going to, positive infinity on the right side. And y goes to positive infinity as well. All right, so then I use the factored form equation to figure out what the zeros are. So this first one right here, if I take 3x squared and I set it equal to 0, that's going to give me x equals 0, and if I take x minus 1 and I set it equal to 0, it gives me x equals 1. But we notice that each of these factors have degrees of 2. So right here, I see that there's multiplicities of 2. So that means that you're going to bounce, right? So for my x-intercepts, I have for the first one, 0, 0. But it has a multiplicity of 2, so we bounce. And then I have 1, 0 with a multiplicity of 2. So we bounce here as well. Okay, so 0, 0, 1, 0. And I know that in each of those I'm going to have to bounce. So I go back and I do my end behavior first. We know we're up on the left and up on the right. So I know this graph's going to do something like this, up on the left, up on the right. So when I come back to the left side, I'm going to come to 0 and I bounce up, and then I have to come back down and bounce again. So it makes this W. Very tiny right there, isn't it? So there you go. Number 2. The degree here is 3. Leading coefficient is -1. Okay, so that is an odd degree with a negative coefficient. So that means this graph is going up on the left, down on the right. So on the left side, as x goes to negative infinity, y goes to positive infinity. And on the right, as x goes to positive infinity, y goes to negative infinity. So I need to find my zeros. So I go to each factor right here. Okay. This would give you x equals -1. If you set x plus 1 equal to 0 and solve, you get -1. And here, this gives you x equals 3. All right, so just in case you're getting confused, this is what I'm doing. I'm taking x plus 1 and I'm setting it equal to 0. You subtract 1 from both sides, you get x equals -1. And then here, the x minus 3, you set it equal to 0. Add 3 to both sides, you get x equals 3. So that's what I'm doing when I say I set each one equal to 0 and I solve for x. Okay, so my intercepts are at -1 and at 3. All right, but at -1, 0, what do you notice right here? There's a multiplicity of 2. So -1, 0 has a multiplicity of 2, and we know that if it's even, you bounce. Okay, so even multiplicities bounce, odd you cross through. So at 3, 0, we're going to cross. So I may give myself a note here and say, hey, you need to bounce right there. Okay? And I'll go back and remove that in just a second. So on the left side, my end behavior over here we said is going up. So I'm going to have something like this on the left and then down on the right. So then I come back here and I know I need to bounce. And I'm going to have to bring this graph over and I'm crossing through at 3. So there's our final answer. And I may come back and erase this word bounce. So there's your final graph for number 2. Number 3, degree. I'm looking at the first equation right here to tell me all this. And really, I'm looking at just this term right here. So the degree is 5. The leading coefficient is 1. So that means you're up on the right, down on the left. So on the left side, as x goes to negative infinity, y goes to negative infinity because it's down. And on the right, as x goes to positive infinity, y goes up to positive infinity. So this time I'm going to find my intercepts, and I'm noticing my degree was 5, so that means I'm going to have 5 solutions, right? So I take this first one, this x, when I set it equal to 0, I just get x equals 0. Here I get x equals 1. Here I get x equals 2, x equals negative 3, x equals negative 4. You take each of these factors, you set them each equal to 0, and you solve them. So x minus 1 equals 0, x minus 2 equals 0, x plus 3 equals 0, and x plus 4 equals 0. And you solve them, and that's how I'm getting these values. So the very first one is 0, so that's 0, 0. Then 1, 0. Then 2, 0. Negative 3, 0. Negative 4, 0. And each of them, if I come back, each of these have understood multiplicities of 1 right here. So at every single one of those, I'm going to cross, right? So I'm going to go back and I'm going to put them up here. So I got a 0, 0, a 1, 0, a 2, 0, a negative 3, 0, and negative 4, 0. Ooh, that was 5. Okay, so my end behavior we know is down on the left, up on the right. So every single one I'm going to cross. So if we look on the left, I'm starting below the x-axis, so I'm going to cross up above it. So I come from the bottom right here, I cross up. Well, every single time I'm going to need to go up and down, up and down, up. So I'm going to cross down here. I've got to curl back up, cross through 0, 0, curl again to cross through 1, and curl again to cross through 2. And remember we said it's, how far down your humps are going is just, just wherever for those really. Because we don't know exactly where they're going. Number 4, I'm looking at the first term again. Okay, so the degree is 4. The leading coefficient is negative 2. So it's an even degree. It's going to flip down. So on the left end behavior, as x goes to negative infinity, y goes to negative infinity. And on the right, as x goes to positive infinity, y goes to negative infinity. So my intercepts. All right, a lot of you guys are going to say, hey, what do I do with this negative 2 in the front? There's no x there. So when you set that equal to 0, you get negative 2 equals 0, right? It would look like this. Well, there's nothing to solve for. So you don't have to do anything with that 2. It's just been factored out. So you just ignore that. So the next one is this x plus 1, and that's where we look now. So when I solve that, I get x equals negative 1. And then this x plus 2, when I solve that, I get x equals negative 2. All right, but I notice right here I have a multiplicity of 3 at negative 1. So negative 1, 0 has a multiplicity of 3. So I'm going to cross, but what kind of cross is it going to be? It's going to be a flatter cross, right? Because at negative 2, 0, I'm crossing as well, but it's just a regular cross because it was a multiplicity of 1. Okay, so I'm here, I'm down on both ends, right? All right. What I'm going to do, and I'm going to use a different color, I'm going to kind of put a straight line at negative 1 because I know that when I cross at negative 1, I need this to be a flatter cross, don't I? So I know that this right here is going to need to kind of go flat there, and then it's going to go down. Okay, so I'm down on the left, and I'm down on the right, and it's flat here. So I'm going to come over here. I'm going to cross through negative 2, and I'm going to loop around and try to make it a flatter cross at negative 1. So by taking that and putting that little flatter place right there, it helped us to see that at negative 1 it had to be a flatter cross because the multiplicity of 3 was bigger than the multiplicity of 1. Okay, backside. So domain and range and all this good stuff here. All right, so most of you guys, I told you need to put arrows here on each of these sides, right? All right, so your domain. Domain is from left to right, and domain is your x values, right? Range is bottom to top, and that is your y values. So if I took a barcode scanner and I started scanning on the left side over here, I'm going to notice I get to this arrow, right? This graph's going to keep going all the way up to it's going to continue to go up, but as it moves up, it's also going to continue to move to the left towards negative infinity. So negative infinity is where we start on the left side, and then on the right side, it's going to continue to move. This graph's going to continue to move down, but as it's moving down, it's getting wider, which is going to positive infinity. Okay, because over here, these x values are going to negative infinity, these are going to positive, this is going to negative infinity, and this is going to positive infinity. So my range, all right, that's from the bottom to the top. So if I go to the bottom of the graph down here, I see an arrow. So it's going to continue to go down towards the y value of negative infinity, and here at the top, it's going to continue to go up towards the y value of positive infinity. Okay. So then my y-intercept is where we're crossing the y-axis, which hopefully we see that is at 0, 3. And zeros are where you're crossing the x-axis. And that first one is -3, 0. And the second one looks like 1.50. All right, maximums and minimums. Maximums are where you go from increasing and you turn and you decrease. Minimums are where you go from decreasing and you turn and you increase. So remember we said maximums are kind of like a mountaintop and minimums are kind of like a valley. All right, so I see a maximum right here. 0, 3, right? So 0, 3 is a maximum, but I'm trying to figure out if I drew a line right here, is there anything above that line? Yeah, it is. So this would be a relative maximum. Okay, so then I come back and I see, do I see a, trying to get rid of that line. Okay, so 0, 3, and it was relative. All right, then I come and I see a minimum value here at -3, 0, and I'm trying to see is there any graph below this line, and yeah, I've got all this stuff down here. So this would also be a relative minimum. Okay, so increasing, decreasing, and constant. So remember, for these, you're looking at x values. Okay, so you're looking at x values here, and you always go from left to right. Okay, so if I go from the left side and I were to put a little fellow standing right here on the corner, what's he going to do as he moves from the left to the right? He's sliding down this hill, isn't he? So we can say that he's decreasing at this point on the graph. So this would be decreasing. And he's going to decrease. He's going to slide down this hill until he reaches this value of x equals -3 right here. Okay? So he started this x value over here. If we look at where this arrow is pointing and we wrote an ordered pair to represent where it's going, to the left it's going towards negative infinity, and to the right it's going towards positive. So it's like my x value here, he was going from negative infinity to -3, and that was decreasing. So I'm going to come write that over here, negative infinity to -3. All right, then at that -3, he turned and he's going to start to kind of climb the hill again, right? Just for a little bit, he climbs until he reaches this x value here of x equals 0. So this right here is a place of increase from -3 to 0. He increased. Then he turns again and he starts to slide down this hill again. And he's sliding down the hill from x equals 0 until down here. Well, this right here, the x values here are going towards negative infinity, or positive infinity, excuse me, and the y values are going down to negative infinity. So the x values here are from 0 to positive infinity, and that again is a decreasing interval. So he decreases. There's a gap, so union 0 to infinity. And he's never flat, so there's no constant. All right, the left-hand end behavior, as x goes to negative infinity on the left, y goes, this arrow right here is pointing up, right? It's going to positive infinity. And then on the right, as x goes to positive infinity, y goes to, and if we look, my x values are going to positive infinity, my y's are going to negative infinity. And symmetry here is none. Okay, next one, number 2 in the back. Okay, so same thing, arrows at the ends. Okay, so domain is left to right, and it's your x values. So from the left to the right, this graph is never going to stop because it's going to get wider as it goes from left to right. So we're looking at negative infinity to positive infinity. Your range is bottom to top. That's your y values. And if you notice, from the bottom, we're at arrows, so negative infinity at the bottom, and we're coming up, and we're stopping right here. Nothing's going higher than this value of y equals 4, so up to 4. And we get a bracket because it is a part of the graph, so it's inclusive. Y-intercept, 0, -5. And then your zeros, your solutions here, -5, -1. So -5, 0, and -1, 0. Okay, maximum, I see a place, right? There's only one mountaintop. That's at -3, 4. And if I look, I'd already put a line here. Is there anything above that point? There is nothing above it. So this is an absolute maximum, and we have no minimum. All right, increasing and decreasing. So we start from left to right. So I put my little guy down here on the left side of this graph. And as he moves from left to right, he's going to start climbing this mountain, right? So he is increasing right here because he's climbing the hill. And he turns. And remember what we said? We look at the x value here, -3. And then he's going to turn and he's going to go down the hill. So he's going to start to decrease. Okay, so the x values here, if we were to write this here on the left, this is going to the left, so x is going to negative infinity on the left, and the arrow pointing down means negative infinity for y. And here, this graph's moving to the right, so these x's are getting positive, and the y values are going down to negative infinity. So the ordered pair that could represent these end values here. So I'm starting with negative infinity for my x. So I'm going to go negative infinity, negative infinity to -3, and then he turns and he decreases from -3 to positive infinity, and he's never constant. So the left-hand end behavior, as x goes to negative infinity, y goes to negative infinity, and as x goes to positive infinity, y goes to negative infinity. And symmetry, line symmetry at x equals -3. Because I can draw a line straight down the middle right here, and I get the same thing on both sides. Last one. Right, arrows on both ends is what we need to add there. Okay, so my domain on the left side, this arrow is gonna continue to go, so negative infinity to positive infinity, and the range this time from bottom to top, negative infinity to positive infinity, because if you come from the bottom, there's an arrow, you're gonna keep going on both sides. Y-intercept, there's a coordinate there for you, 1, 2, 3, 0, 4. And your 0 here, only one of them at 2, 0. All right, maximum, minimum. That is where you go from increasing to decreasing or decreasing to increasing. And I don't see any here. All right, so these are going to be none. Okay. All right, so increasing, decreasing, constant. So from the left side, this little fellow would start to go down this hill, right? So he's going to decrease right here until he hits this place right here. Well, actually, it's going to continue to decrease here. It's still curving. So he's decreasing until x equals 1, right? So we're decreasing from negative infinity to 1. And then it turns. And what's he going to continue to do? I shouldn't have written that down, should I? because what's he doing here? He's actually going to continue to decrease everywhere, right? It just kind of looked like at first that maybe there was something else going on, right? But if you notice, even though this is kind of going flatter right here, he's still going to continue to decrease. All right, so he is decreasing. I'm just hitting all kind of buttons. He's never increasing. He's decreasing from negative infinity to infinity, and he's never constant. And even though it's flatter right there, okay, even though it does go flat for a little bit, he's technically still decreasing. And because we can't really see an exact place of where that graph flattens out either. So we're just going to say that he's just continuously decreasing as he goes down that graph. Left-hand behavior, as x goes to negative infinity, y goes to positive infinity, and on the right, as x goes to positive infinity, y goes to negative infinity. And symmetry. So the only thing that I could maybe see here would be rotational. So I'm going to do this so you can see it. Let's see what happens here. I put this graph here. Okay, I'm going to select it and I'm going to rotate it. So let's see. If I were to rotate this 180 degrees, this is where I go, right? So is there any symmetry? No. So we have none. So that's it.